So when I was reading the textbook in chapter 15 on nuclear technology, and specifically the bit about fission and versus fusion and which elements tended to be more predisposed to which, I found one sentence very confusing the first time I read it. It showed the graph, which had the peak at about 60, and it said that elements whose combined A is less than or equal to 60 are more predisposed to fusion, because afterwards their combined binding energy would be greater than it was before, and thus energy would be released. Greater per nucleon, I mean. And I totally got that it would be greater. That made complete sense looking at the picture, but I didn't understand why that would mean energy would be released. The same thing for the ones with fusion greater than 120, then if you break them apart, you get a higher average binding energy per nucleon, and then energy is released. It was the energy is released with a higher binding energy that got me really confused. I was thinking, if the higher binding energy is bigger, surely that energy has to come from somewhere, and therefore it would take energy for that would happen, and it wouldn't want to naturally happen, and it wouldn't release energy. However, then I started actually thinking about what binding energy was, and the way that helped me with this problem was not looking at the equations, but just thinking about what it actually meant. And so binding energy is how much energy you have to put into a system to break it apart into its component pieces. And the component pieces are always going to have, like, once you break it apart into all its pieces, it's going to have a specific set energy. So if the binding energy gets bigger from a certain state, that means that you have to put in more energy to break it apart than you did before it got bigger. And that energy can't just have gone into the ether. It has to be released by conservation of energy. So when you get a bigger binding energy, you have to put more energy into it to get into the parts. And therefore, by putting that's a higher amount that you have to put in than before you increase the binding energy. So that difference in energy has to have been admitted into the system and just outside the system. And therefore, that resolves the confusion I felt that higher binding energy, yes, the binding energy is higher, but that actually means that the overall, and that means that you need more energy to break it apart, and therefore you have to have taken some out. And the stuff you've taken out is the energy that is released, and that is why they naturally want to go to the slightly higher binding energy per nucleon, and that is why the ones below 60 tend to be more prone towards fusion, and the ones above 120 tend to be more prone towards fission.